So what I'm going to do in this, guys, is I'm going to go through and explain all the concepts that we've learned so far and review them. So if you had any issues, I'm hoping this will give you the opportunity to go through them and really understand them. So the first thing that I'm going to talk about is independent, dependent, and controlled variables. Now, I love just teaching with examples, so I'm just going to do that. So for the first case, I'm going to create a lab in which I take my snakes. I've got 2 of them. And I'm going to feed them, mice. And I want to see how the number of mice they eat impacts their growth. So for one of the snakes, I'm not going to feed him any mice. Okay? And then for the other one, I'll feed him, let's say 2. And let's say I get another snake and feed that snake 4. And get another snake and feed him 6 each day. Now, what the independent variable is what you as the experimenter get to control. So in this example, I am controlling the number of mice, so that is my independent variable. Now, your dependent variable results from whatever your independent variable was. So for example, in my case, the dependent variable is going to be the size of the snakes. So as a result of the independent variable, it's going to impact the dependent variable in a very specific way. So independent, in my case, was the number of mice. I got to choose that in the lab. The dependent variable is as a result of the number of mice, how much did the snakes grow? Now, for controlled variables, these are all things that could potentially have an impact on your study. So, for example, things that I might be concerned about. I might be concerned about the amount of water that the snakes are given. I might be concerned about the size of their cage, because all of those variables, the size of the cage, even the gender of the snakes, anything, right, could impact this relationship that I'm studying. So I'm wanting to keep these the same. I'm wanting to keep them in the same cage, have them have the same amount of water, have them be the same gender, just to make sure that that isn't causing the relationship I'm experiencing, that I'm witnessing, and not how many mice are impacting it. Because let's say, for example, female snakes grow slower than male snakes. I might think that eating, let's say, my female snake who eats 4 mice grows slower than a snake that eats 2 mice a day. Well, then in that case, I might assume that fewer mice means that they grow more, which is wrong because I didn't control for gender. So gender might impact this relationship, and therefore I'm going to keep it the same to make sure it doesn't impact my study. Now, the next thing that we talked about was place values, and this goes back to lower school. But if I'm talking about this in class, I want to make sure we're on the same page. So this one right here, because it's to the right of the decimal, this is going to be my thousandths place with the THS on the end. This is my hundredths place. This is my tenths place. This is my ones. Notice no ths at the end anymore. This is my tens. This is my hundreds, and this is my thousands. Now, we're going to be rounding based on this very soon, so I just want to make sure that we're comfortable with those terms. So thousandths, hundredths, tenths, ones, tens, hundreds, and thousands. Okay? Now, the next thing, we're going to be using this, I'm going to be assuming that you know how to do it, so I just wanted to go through this quickly as well. If I give you a decimal, like this one, and I ask you, I say, okay, go ahead and make that into a percent. What you need to do is recognize that this is another way of writing it like this. 82 over 100. Now for both of these, in order to get it into a percent, what you're going to do is move the decimal place over 2 places, or just multiply by 100. So for this one, all you do is multiply by 100, and what you'll get is just 82. Okay, so nice and easy, and this is 82%. Okay? You can either just multiply this by 100, or as I just said, by moving the decimal place over 2 places, you are effectively just multiplying by 100. So I'm going to move it 2 places to the right. 1, 2, and I get again 82%. Now, the reason why this is important, what if I give you the reverse? Let's say I give you, I don't know, like 79%, which you will experience at some point being given a percent, and I ask you, okay, go ahead and make that into a decimal. Okay? If I ask you to put that into a decimal, what I'm effectively asking you to do is divide by 100. So rather than moving the decimal place over 2 places to the right, what you're going to do now is move it 2 places over to the left. So 1, 2. So what you'll get if I ask you to take a percent and make it into a decimal, you get a number that looks like this. Okay? Remember, the other way of writing a decimal, if I'm going to write it as a fraction, I could just write this as 79 over 100. Okay? So this is the fraction, this is the decimal. We'll normally be using this, the decimal, not the fraction. Okay? Last thing, solving equations. Now, this might be something that's really easy for you guys. Awesome if it is. If it's not, you really need to practice with cross-multiplying, because what I have found is that a lot of chemistry students do not cross-multiply. Instead, they'll see a reaction like this, or sorry, an equation like this, and they might multiply by 12, divide by 3, I don't know what they're doing. Okay? If you're seeing fractions like this with an equal sign on either side, what you need to do is cross-multiply. So you're going to multiply 4 times x, and then you're also going to multiply 3 by 12. This is cross-multiplying. So what that effectively does is gets my x out of the denominator. So what I end up with is 4x, okay? And then I'm going to set that equal, sorry about that, 4x equals, now 3 times 12 is 36, so equals 36. Now, I'm not quite done because I'm still trying to solve for x. So what I now need to do is divide both sides by 4. And that way you get x equals 9. Okay? If you multiplied by 12, and then the issue is that the x is in the denominator. So whenever the x is in the denominator, you want to be cross-multiplying. If x were in the numerator, like, I don't know, let's flip this reaction. So x over 3, sorry about that, equals 12 over 4, okay? In this case, if you want to multiply this whole thing by 3, and that'll help you solve for x because you'll have gotten rid of the 3, so multiply by 3, and you now have x. That's fine if you want to do that. But when my x is in the denominator, you need to be cross-multiplying or else you will get the wrong answer. Now, if I see an equation like this, I still cross-multiply. I still do 4 times x equals 3 times 12. I still do that. It's up to you what you decide you want to do. Okay? And that's it.